it down, and then you would be able to proceed. So you see now the carriage is getting back because he finished to push the beam or the last move, and then you go back to load a new part. So when it will be here, the operator is able to load the new one and start the job. All of this is controlled by the HMI there. They don't need to be close to the conveyor, and this process is automatic. It's not controlled by the operator there. It's through the sequence that after the last move, automatically we'll get back here, waiting for the next part to be done. But like you are seeing, the robot still cutting because the last move have been done. So right now he's just bringing his lifter or dog bones to move the beam to this location, and he just creates some free space for having the assistant to load new beams there. So now we are seeing the dog bones. Because he pushed the last one, he's not able to push both together, so he needs to grab this one and then he will transfer to the roller. Against the vertical reference, and we got sensor.
I was afraid if this one out of the roller.
Yeah, no, I don't know. Oh, he's good. You see the system still cutting? The best operator that I'm seeing from our system will load their next part while the system is cutting. Some will wait the robot finish cut,
yes.
And then load, but then you got a gap of time that you're not using the system. So you lost time. This is the best technique, but it's not all of
some other machines, we cannot load the second beam.
Can we have learned listen from customer?
The what?
Learned listen.
The list?
Learned listen.
Oh yeah.
As the instruction or configuration.
Yeah, our technician will give you the best advice for operating our system, but it's not actually all customer who respect that. But this one is really good. When I'm seeing this technique, it's the best. I'm pretty sure if we look the efficiency of that, guys, it will be something like 60 more. Because we monitor through a shift. Let's say the shift is starting at 8, finishing at 4 in the afternoon. And in the system you put that you're taking a break of 1 hour. You will calculate the time between this program and you took that amount of time to start the other one. So it's calculate the running time over all the time, it's calculate there in efficiency.
Why he push this one to be
Oh, it's through the sequence that it's go back a little bit. So there is a locking sequence there. Usually you want to separate your beams inside the robot cell. So it's okay. So you just cancel and then you will be able to restart the sequence. So the sequence is the beam will move inside to get the 0 at the beginning. So when the 0 is done, you got the clamp, it's clamping the material, and then you got the follower who will get back and then know exactly what is the length of the material. So you could not nest, or nest is mean use programs or part that will be longer than your raw material. It will say, oh, I'm not able to produce your nest because it's too long for the material you load. So this is really the best for getting to avoid scrapping material or just re-weld material together because you're missing, you just missed that the raw material was shortened than the path that you did. So unfortunately the gas missing. So you got the feedback that his nozzle are empty, so you're just managing to change it.
working alone.
Yeah, finally.
This is oxygen.
Oxygen, air, and nitrogen that you need. There is 3 gas to cut steel. The nitrogen is used when you start the arc. It's to get more longevity over the consumable. It's part of the XPR technology. They put that. Before it was only oxygen and air. And today they add the nitrogen. Now the cycle is starting. So inside the cell, I will show you, there is a 0 beam sensor. So it will pass through that sensor really fast, and then go back really slow. So it's good to be sure to detect the beginning of the beam. So the 0 is done. Now the pusher is getting the bag. So then after they will know exactly what is the length of the raw material. And they will check if it's long enough to process all the nests that have been done and put in the interface. Considering that you got front cut, the first cut, kind of because we're always cutting to get straight cut, and intercut. Between the parts you got another small waste of material there. So you calculate all this and you say, okay, you're good with your receipt. So now the process is started. So we can move to the central unit. So after that, when the system did it, he will move the first, he will do his first movement, that is request to process the feature like holes, comb, scribing, and the robot will measure each face of the beam to get the mill tolerance. Mill tolerance is what is the width, what is the height, what is the fixedness of the part, and then he will cut after.
Ça vient juste de voir comment la job avance,
c'est ça.
le measuring device, tout est... Voilà, peut-être ça, si vous voulez, pour la dernière job, je peux vous montrer ce que je vois dans...
Ouais, ok, vous avez une pièce, tu dois placer. So the scrap bin, so it's just getting everything. So you see the 0 point have been done, and the first move have been done too.
Why this door is open?
Oh, you want to clean the place. That's why. You could use the tabbing function to keep that remaining part to the other, but by falling there, he's able to. We're going to go and test that. So you want to clean right now, but it's possible to keep attached that drop to the beam and just get outside after.
What do you say this? I open this door.
Everything is safe. The robot can move. When the door is open, everything is safe. The door, when he requests to open the door, it stops the
They
cycle.
will activate this
Yeah,
door.
you activate the request to open the door.
Yes.
So it put the system in pause. Then
But if they look, yes, I try to open. If you open,
it's stuck now. But if you unlock there, it would just open by itself. It's a safety, right?
Even if you force it open, it will stop the job completely.
Yeah.
As a safety measure.
So you look at the camera, I think this is the best view. You look at the thing. So what you are seeing here, right now it's in the process of cutting. So it's mean all the process of measuring have been done. So we'll look the next cycle, but the process is always the same. We move the beam. When the movement of the beam is done, the clamp is just set up against the vertical reference, and the robot head will measure the 3 face of the beam, and then it will cut. But it will use the previous measurement of the face to offset and adjust its cut to the part. So right now what we are seeing is the last process, so it's cutting. If there is marking functions, it will scribe and mark before. Because we got through the past some experience where people were putting scribing in the cut. So there, right now we don't have this issue because we scribe first and we cut after. And it's always the web first and the flange, because if you start with the flange, you will put slag over your web, so then after you create the list. So it's always web first. Web is the horizontal phase. So you see there, you will have a kind of one drop. So it's possible to create some attach. Je vais juste montrer pour ici. So it's possible to keep the material attached to the. Here you will change your distance. So you will create a small attach that will bring the beam outside the drop with your beam. It's case by case how people want to operate or use this function. In that case, it's not used, so it's just falling there. But because they're cutting only on 3-phase, it's not that bad. That's what I mean. When you're cutting 4-phase, your robot head is going underneath. So there, sometimes you need more space. So you see here the sequence, the beam have been moved. So now it's clamping over here. Now the robot head using his laser to measure the phase. We'll use the web, flange, and then after it will cut. It's always the same concept, except it's really fast. It's not touch sensing with the tip. Tip is bad because you need some water sometimes to create an electric transfer. So laser is really fast. I will show you if it's possible after.
The normal speed for the beam cut is it this fast now? On average?
Yeah.
Okay. Okay, so it wasn't just our machine that was a little slower before, but now it's the new average for the speed.
Yeah, it's the normal speed.
It makes sense.
Yeah, with partners, we're doing the updates. So that's why you receive the updates. As-tu le rapport aussi? Le rapport d'efficacité, je serais curieux de savoir si tu l'as. Tu suis ça un peu? On donne pas.
Moi, je ne check pas souvent, mais lui là.
Et tu dois être assez haut, toi, mon expliquer. Does your operating time is 7:30 to 6?
Pas exactement, mais c'est à
What
peu
is-
près ça. Ouais, c'est 7 à 5.
Okay. Let's say we put here 7. One backspace.
Je sais pas si.
Moi, j'ai demandé ça un autre côté. En gros, il set up des dates. Ça, on va dire, mettons, la journée de.
Oh, peut-être. Je pense lundi parce que hier, j'en ai pas fait beaucoup. J'ai fait de la peinture la moitié de la journée.
So, like you mentioned, so this is the efficiency of the system, so you're able to see what is your efficiency. That you just used the other day. Because yesterday you paint and you operate the system, so that's why it's not that good. Mardi, ça reste dans l'eau.
Ouais, mardi, ça aurait bien de l'allure. J'ai fait de la découpe toute la journée.
So you see, this is the what you're getting. So it's just telling you number of piece cut, the average time per piece, number of tonnage, and this it's kind of stuff that helping to monitor the production of the system. Okay. See all the beam? That is out. So you get the beam measure, and even if the beam is larger, because the fabricator of the beam could be larger than the spec, than nominal. So that's why it's like that.
Now, you caught me at a bad time because I am about to change the consumables on the head because the cuts are starting to look bad. That is a lot of scale to have after a cut, but I'm just on the verge of changing the consumables. It usually looks a little prettier than that.
It's not bad.
It's a good time for us to meet.
Yes, yeah, you can see it at its worst, so at least you'll know what to expect.
Like you could see, all regulators on the machine are provided, but you need to supply regulators to the wall from your bulbs, and you are able to control the gas regulator there too. So you got the electrical panel, same as you saw over our new generations. The BC25 is like part of the new generation for but it's the same concept, right? Panel, the robot. It's using air cylinder for cutting, no hydraulic. In your case, because of your location, air cooling will be provided there to keep that with a good temperature. to show you the feature and how it's a hard place to be and how we manage this hard time inside with protector and how we protect our cable and all those small details we put all together to get as low as possible the maintenance and the downtime over the equipment.
We shall have
The what spark out? Usually there is no spark out. You saw view?
Yeah.
Okay.
So you can see the gap there. Another side.
Maybe the sliders have not been set correctly at the installation. Just a little like this.
Would you like me to zoom in?
Yeah.
That is the most important one.
The same camera we can access remotely on the phone camera.
The interface is great. The interface is really his user friendly is more complicated one.
I would say it looks a little jarring at first, but it's more user friendly than it appears. I would say the main buttons are right here. The tabs. I would say it took me about. The first month was a little complicated to get the user interface to an understandable degree, but I would say the most complicated is this right here. This little thing that has all the buttons and the functions. It is the best tool to control the arm and the laser and the beam cut while you're operating the job, just to fix little mistakes here and there if ever it misses its alignment, or if the cut for some reason or another hits the beam, that'll put a stop to the job and you'll have to manually replace the arm. So I would say that is more complicated to learn than the user interface. It's not even comparable.
So how many months as I can say I'll be expert?
I would
months,
say 2
3?
months. 2 months to 3 months, you should have a good understanding, almost a complete understanding of this, and it will really depend on the error messages you get. Practice makes perfect. At first, I wasn't able to use this at all, but you know, after you see the same problem 2 or 3 times, you'll lose a bit of time, half an hour trying to fiddle around with it, but once you get the hang of it, the same error messages will come up most of the time.
So you got trained from Matitech or this is self-trained?
Pardon me?
You got training from Matitech
Yes.
or this is self-training from your side?
It's basically when they come set up the machine, the technician will explain to you the main problems that will reoccur.
Yes.
But after that, you're pretty much on your own, but you can always call tech support.
At the time you called them many times to solve the issue or you manage yourself?
I would say the first month I did call them a lot.
Yeah.
I did call them a lot. After that, a lot less often, and now it's pretty much once a month when there's an error message that I just cannot figure out. But apart from that, I mean, it's really the same 3 problems that reoccur. Usually the laser will not align to where it needs to cut, so I just have to place the arm where it needs to be. Sometimes it does hit, especially when the scale is quite big. Sometimes it interferes with the way the arm moves. So sometimes I just have to either skip the rest of the little cut that's left and have the welders do it by hand. But I would say it looks intimidating for sure, but it's easier to understand than it looks.
Thank you.
No problem. Ça a l'air utile à la manette.
Not so bad. Are you using the knowledge base or knowledge base? The online functions of the
Moi, je vais utiliser des fois. Moi, souvent, quand ça me donne un petit message d'erreur, ici, je vais checker c'est quoi, ça m'enligne dans le bon chemin.
So what he mentioned is sometimes when he's getting errors there, he's looking the online portal, like I mentioned, and he's getting his answers. And each day we create new articles. When you buy a robot, you buy the arm, you buy the controller or the servo motor R, and you buy the teach pendant.
What's it called?
Teach pendant. It's kind of the control of moving the robot arm and to and to configure the arm. In our case, the teach pendant would be mainly used, like you mentioned, to like move the robot a little bit. We got automatic functions to get back from locations to home, but sometimes you got collisions, like flag or something have not been doing correctly, and the robot jammed there. So in some cases you need to move it manually. Then you need to know the sequence.
Tu vois, il a pas l'air de marcher dessus tout. Mais honnêtement, là, c'est peut-être juste la petite poussière qui accumule dans le USB. Old one. So this is like what remained from the previous job. So the good part have been dropped on the other side, and this is the drop that would go maybe crashed in or something. This one is the same piece. That it's there is no limit. Each beam there, HSS, big one. There is no angle in channel, but it shows you connections there that are done.
ask him for the smallest size for Angular.
The smallest size, I don't know if he, you know,
If he made it or not.
it's part of the programmer. Mean the length or the size?
Angle, small angle.
Small angle.
Less than
The thing is, we could do simulations for you on a smaller one. If you got a drawing, we could simulate the system and sending you the simulation. If you got a drawing of the smaller one, we'll just create the simulations and send it back to you the cycle time and show you that it goes to our cloud. The thing is, our clamp is able to clamp until 0. And just like I mentioned, the smaller profile are sometimes bent and it's a little bit more complicated. Right now it's going through the process of calibration because from the accuracy and quality of cut they are expecting, they just found that they need to recalibrate the system. It's easy like this. So you unscrew the head and then you will change mainly 2 parts, the receptacle and also the electrode. There are mainly the 2 parts you need to change. The other one a significant
will be trained to do this.
the what?
Will be trained to be.
Yeah, totally. And you got also over the HMI total numbers and all the parts should be set and procedures. Yeah, it's part of the training. This then you got pictures. Here. You got got all the numbers, depending on what you want, that are showing you what you set to work with. So you just assemble in that thing. Depending on the consumable amperage, you just follow the number. So each part are marked with a number on it. So you change those parts, you put it together, and it's part of the consumable. It's the same concept of the table for the bean cut. So someone that is trained for the bean cut do the same over the table and vice versa. We could use that time during exchanging the consumable. Like you can see, all sensors are protected. Here you got a sensor to get the 0 of the beam at the beginning. There you got the sensor, you see the red dot there. You got a sensor for measuring the beam. And also we got a protective lens that is a side that you slide out. Then you are able to replace. So this one is really cheap. So you avoid burning your sensor. This is a pneumatic, so when it's not used, when closed, when it's cutting, when you need to cut or to measure, it will just open. So during the cut, it's protective itself, and after that. And if you look, there is no cable exposed, everything is protected through a cover or something because it's really bad here. If you look, it's dust, it's slag, so that's why we took a lot of care to protect the cable. If you look here, without that protector, cable protector, it's have been burned.
Shall we clean this one during overall?
Depends on customer. Some customer will clean each week.
Yeah.
You will get more longevity of the system if you clean it regularly.
Yes.
So it's dependent on you.
Okay.
Some customer will not. They don't have time. Some other will take
Just
time
add it
because
in
they
the
want.
recommendation.
Yeah.
Added this one in the recommendation.
Yeah, to create a kind of routine. So
Yeah.
it's nice 1 time a week. I think that's nice. Wait, Rob. So it's really a quick connect, so it's you unscrew and you screw. And also you could prepare a new one. So you could have like two heads like that and you just swap, and while it's producing you just replace your consumable. So it's another way to optimize your production. After you change the consumable, you need to recalibrate because the consumable sometimes process is not really centered, and because of the accuracy we want to provide you need to go through a process of calibration. And it's all automatic. It's close to be automatic.
Every time you change either you change the consumables or you change the amperage.
It's all indicated here what you do, step by step.
That is the easiest thing to learn.
Yeah.
Pretty much the first thing you learn and the thing you're going to be most familiar with is really every time you change the head or you change the consumables, always go to the calibration page and all the instructions are there, so there's almost no way to mess it up.
Yeah.
Almost.
The most important things of the system, if you're well calibrated, you get accuracy. If not, you would just get no accuracy from our system. So right now it's taking the height, the first measure, because the process of the plasma is not able to giving us feedback. We need the guys to measure things. That's why he's having a caliper in his head. He did his first measure of the distance of the plate and the tip. Now he's inputting the value there. So we continue the process. The next step, we need to cut a small, we will see, but it's a small rectangle. From that rectangle, he would do the same, measure the size, put the value there, and update the value. And then the robot will know now where is exactly the process with itself. It's mathematics behind, but it's part of our solution.
Alright, let's go pick it up. Pardon me?
Did you cut the smallest angle before? 2 inch? Smallest.
Smallest.
I can see huge beam.
This is a cut that is about 0.2 inches. Just about?
No, I mean a small angle, 50 by 50 mm. I can see only huge beam.
Yeah.
But you didn't cut before small channel, small beam.
Oh yes. Depending on the thickness of the steel, that is what will determine the amperage, either 80 amperage or 130. For the biggest ones, we don't have to use it as often, but for the biggest beams we have, we can use the 170. But for this machine in particular, I don't, and what material we work with, we don't need to exceed the 170.
Yeah.
We barely use it even then.
You are doing multitasking.
So that small sample helping you to know if the consumable that you are set are good, because you check the cut quality at the same time, and also you take the dimension of the size, and you would just input the value there. live indicate the process of the system.
Cycle started.
There's flashing. What it
Yeah,
means?
green.
Flashing is running. Solid green is running. Flashing is waiting.